Ralph did such an excellent job. I'm going to explain a little bit about blockchain, but he did such a great job. We'll probably just get right into our use case. But just showing you the benefits. So usually the problem, like what Ralph was talking about, was centralization. There's falsification, tracking. You might have a manual record keeping problem, data silos. Um, you'll see what you get out of the box with blockchain. You get all these extra benefits. So you get encrypted and distributed databases, immutable records, full transaction history, smart contract automation, which we'll get into that, where smart contracts aren't necessarily contracts at all, but they have this automatic execution that's really nice that they provide, and then the interoperability capability that blockchain brings when you're kind of bringing in all these disparate systems between different suppliers and customers, and really blockchain is a team sport, so you're really looking at these kind of consortium based teams that you're bringing together. And then you can see the whole benefit, and just kind of bring up the diamond thing. You got the tamper-proof logo right there. So just really interesting behind the benefits of what blockchain can bring. And the characteristics are compelling as well. So we're usually looking at like a business network. So you have identifiable business process or networks that you have connectivity to. There's some siloed repositories that you're trying to kind of bring together and have that kind of one single source of truth, because you're always like, even time inventory reconciliation between, third-party logistics providers and different things like that, between the OEM and then into the supply chain. Obviously, blockchain use cases really provide when there's multiple writers. So if you have multiple people writing to the same system, that's where it works out really well. Having a minimal trust factor, you just want to be able to have a capability where you do trust that we're in the industrial space. We're looking at that private permission space, so you do know who you're doing business with, as opposed to a public blockchain. And then there's obviously some dependencies in the process, so that's where the smart contract comes in, where there's certain things that have to get executed, and when those things get executed, certain things are then take off. And then you have business rules. You have shared rules that you're working together on. So I'm going to turn it over to Emily right now, and then we'll kind of bounce back and forth with this use case we did between our consortium.
Thanks, Joel.
Yep.
So my name's Emily Jerger. I am a project engineer for MXD. And MXD is the Digital Manufacturing Institute. It's one of 14 institutes set up by the government under Manufacturing USA's network. And basically, we're a research collaborative consisting of nearly 300 members coming from industry, academia, solution providers, and government. And our goal is to spur the development and adoption of digital technologies for manufacturing by leveraging expertise from our consortium on collaborative projects in order to solve problems that are really too big for any one organization to attack on their own. And you'll see this really well demonstrated with the list of participating organizations at the top of the slide here. On this project that we're going to be kind of talking about, where there was a blockchain implementation, Dow served the role as the end user. We had ITAMCO and their affiliate Simbachain, from which Joel is speaking from, on the project. There were two universities, Indiana University, Purdue University, Indianapolis, IUPUI, and Rochester Institute of Technology, and lastly, Microsoft. So the problem this project really aimed to attack is that manufacturers are often faced with outbound logistics issues where their logistics are impacted by events that current supply chain event management systems, SCEM is our abbreviation, they're not really addressing currently. Primarily, sensing and being able to provide advance warning of these events, such as weather events or port closures or social events, traffic events, that would really impact delivery schedules at the end of the day. They are not objectively assessing risks across the enterprise similarly, and they're not proactively mitigating the impact of those risks to their delivery schedules. And while there are many existing solutions out there for supply chain management, visibility, for predictive analytics, for risk detection, There are typically, these are not connected, and that provides a lot of data in many silos. Processes to detect these disruptions are often highly manual. Typically, the process from detecting an event, assessing the risk, and mitigating that often for DAO take place in war room meetings, is what they call them, where a bunch of supply chain managers are getting around the table and trying to make decisions, but they're often based on very little information because data is on all these silos. It's hard to track down in the moment. And at the end of the day, customers for DAO and for many manufacturers are negatively impacted when their delivery schedules are not accurate or when their deliveries are late. You hear talk about the Amazon standard, basically, where consumers and customers are now demanding complete visibility into where their shipments are and then an accurate prediction for when that shipment will arrive. From an end user perspective, you can kind of zoom in. Imagine yourself as a supply chain manager. You really want to have a tool that predicts supply chain disruptions, analyzes the risk impact to your organization, and then automatically mitigates those risks. And then communicates all of that information nicely to you in a targeted communication or alert so that you can ultimately reduce the response time it took to respond to that risk. You can reduce the disruption incurred freight and manpower costs and ultimately improve your customer service levels. There we go. So to narrow that down a bit for the scope of this project, this team really sought to demonstrate and validate a connected framework that would allow you to predict future external outbound logistics risks, prioritize these risks systematically, predict mitigation plans that dynamically map across your product movements, then deliver all those targeted and tailored communications to the right people at the right time to drive those rapid responses in the supply chain when humans are really needed. And lastly, to be able to display effective performance metrics in an easily visualizable way to support future improvement in system and in supply chain performance. And ultimately, the goal of this demonstration and a proof of concept was to achieve benefits of increased data completeness, so solving those gaps in where data isn't existing, reducing the response time to supply chain disruptions, and ultimately, increasing on-time deliveries so that employee experience goes up and customer experience goes up. So to understand what we mean by this framework, it's first really important to understand both the baseline and target workflows the DAO was looking to achieve. So in the current state, where we started, the events or these supply chain disruptions were found very manually by experts, and then the risks were assessed by those experts. Typically a subjective assessment, kind of depending on the person who is handling it. And then a supply chain manager would be notified by email or by phone by this expert. That supply chain manager then would take a mitigation action, but that action was typically not recorded. There were data gaps there. And then lastly, a customer service representative would be notified of any changes by email or phone again. And what this caused is a lot of time that it took to get from notification that there was an event that was disrupting their supply chain to the time where an action was taken. So while we were looking at that current state, we were really looking at how could we innovate while really leveraging this expertise, this asset that DAO currently has for their supply chain managers. How can we work within that existing culture? So going forward to the future state and what the goal was for this project, we wanted to shift from subjective to a systematic approach. So some ways you'll see at the very beginning here is by doing an automated search for disruptions by scouring different data sources from weather solutions, traffic solutions, and social solutions like Twitter to be able to understand what what those events are and predict, using that data, the delay that those shipments will cause. Then we wanted to be able to systematically assess those risks, making sure that that's more of a objective assessment, and then being able to recommend mitigation plans to a supply chain manager so that they're making consistent decisions across the enterprise. And again, we wanted to leverage the expertise that the supply chain managers provided. So we actually wanted to make a human-in-the-loop system that got rid of any unnecessary steps, automated those for the supply chain managers, but still leveraged their expertise. So you'll see on the top here, we have a manually identified disruptive events. That's for anything that the automatic scouring of these data sources misses and that these experts can bring to the table. We wanted to make sure that was incorporated. But we did automate notifications to supply chain managers. So that was instantaneous communication to the right people. And same goes for automating communications to other users like customer service representatives. And lastly, we wanted to make sure ultimately that our supply chain managers were able to make informed decisions. So to do that, we made sure that they had ideally a recommendation for what mitigation action they should be taking, but mostly that they had all of the data that they needed collated together in one system from all these disparate sources so that they can make that decision quickly. And to do that, we also decided to record the mitigation actions that were taken so that they could then feed that back into a recommender system and make those informed decisions better the next time. And also have a performance metrics dashboard that will allow them to visualize how they're doing and make sure that the business managers can make better decisions going forward. And lastly, this was an ideal target test case for blockchain technology because it involved distributed siloed data and process dependencies that relied on multiple actors. So we've already talked about kind of what the ideal use case is, and that's kind of why we approached blockchain for this project. But when we started this project, we actually came across a lot of questions that we think anyone should really be answering before they get started with any kind of deployment of blockchain. First and foremost, what is the business case for blockchain? We wanted to make sure as we started this project that there was an actual business problem that we were trying to solve, a manufacturing problem that we were trying to solve. Did blockchain meet those needs? And then if it does meet those needs, is it the best, most cost-effective solution to meet those needs? And the team definitely had some challenges in trying to work through what is that value proposition, what data do we need on that? And that gets to my next question, which is what data do you actually store on the blockchain? There's so much data. We've been talking about all this data, and not all of it has to be stored on the blockchain. There's not a benefit to that, and there's actually a cost that comes with that. So we considered, what data elements need to be stored on the blockchain. That really needs to be coming from the manufacturer, providing that end user, providing that requirement. And then there's questions of, do you store that data on chain, meaning actually on the blockchain, or do you link to it with an off-chain hash? We also tried to debate about whether or not we use smart contracts, which again are just a set of rules that dictate what goes on the blockchain and how those business rules work. Do we use those to define all the data exchanges between software modules? So you'll see later in our architecture, we have a number of software modules that we're bringing in to this integration architecture. Is all of that funneled through blockchain? Is there a reason to do that opposed to other API systems? So these are all questions you should be considering when you kind of get down to the nitty-gritty. Again, access control and authentication is important. Not every blockchain solution is going to come with that automatically. You need to be thinking about that proactively, making sure that your data is secure and that your users are the right users for that, especially on public blockchains, of course. Should we use it for a platform for communications? Do we send all the communications through blockchain? And we did some experimentation with that, honestly, to kind of figure out how that would work and what it would look like. And then, as usual, is it scalable and is it extensible to other vendor solutions so you can keep up with technology over time? And I think that in this case, SymbiChain was great at interfacing with all of the solutions that we needed to. So quickly, I'll just go over an overview of what the project consisted of. And I know blockchain is a component of this, but it's important to understand the context about all the other puzzle pieces where blockchain kind of came in to that piece. So this project demonstrated in a proof of concept an integration framework for connecting modular supply chain solutions that presents supply chain managers with information that they need to make the most informed decisions systematically and efficiently. So first and foremost, we developed a predictive transit model, which is a set of software algorithms that takes input from weather data sources, traffic solutions, and social solutions like Twitter to be able to output a predicted shipment delay. That was the purpose of that software module. It interface then takes all those predicted delays and puts them into a risk assessment software module, which is a set of backend algorithms for systematically assessing risks based on business metrics. And then it also contains a user interface that allows you to input manually identified disruptions in addition to those automatically identified disruptions. It kind of maps them across all of your shipments in a visualization. We developed a mitigation planning software module. Real basic, it sends an automated notification to a supply chain manager to tell them that there is a risk for a shipment that went above their acceptable risk threshold. And what they're able to do then through that module is actually be able to input data to record the actions that were taken for that mitigation plan. Lastly, there's a performance analytics module. Again, it's a basic dashboard that takes in inputs from all those other modules and displays important business metrics so they can view those updates in real time. And underlying all of this, as I said, is a blockchain communication system that's integrating relevant, emphasis on relevant data from all of these modules through the SymbaChain app to the blockchain, and it ends up sending automated notifications then to specific users based on that data. We're calling those subscribers. So you'll see how that works. It's basically the communications experiment we did, see how you would end up using that for communications purposes. Just going to flash this up here. Don't expect anyone to be able to read this. Just a demonstration of our overall system architecture and how much went into connecting disparate solutions. And this is what challenges manufacturers are facing, is really narrowing down how do you take all these existing solutions that work well for them but aren't connected in a way that they can pull together and utilize for insights. So we'll simplify it down a little bit. On the left-hand side, you're going to see all of the data sources that were brought in. This includes real-time visibility solutions that give you real-time GPS data of where your trucks are, for example. Internal DAO supply chain data, which is very important for model training, of course. Being able to pull in all these user inputs. You're going to see a lot of users over on the left-hand side, as well as event data from Twitter, INRIX, which is a traffic solution, and NOAA, which is a weather solution for that event data. And it pulls all of these into a centralized database, which all of the push data to and from each module. And ultimately, each of those modules has a smart contract that's pushing data to the blockchain. So as you saw in that last diagram, there's a lot of users. We have at least 5 or 6 or 7 different users who are touching this very complex supply chain network for logistics management. So we have business unit managers. These are the people making the decisions about thresholds, risk thresholds. We have supply chain managers who are our target users. They have the expert knowledge for event detection, risk mitigation strategies. And they're able to communicate with customer service representatives who are the ones sometimes making those mitigation decisions and determining based on cost features, of course, and those decisions. We have supply chain planning professionals who are taking in all that information about the delays for those expected shipments and making adjustments, ultimately to be connected with an ERP system. And then lastly, a system administrator who's helping maintain this complex ecosystem from the back end. So now we're going to walk through a quick demonstration and a visual so you can see what it would look like to go through kind of a workflow. So imagine you are our DAO. DAO has a priority customer who places just-in-time orders. The typical trip between, say, Houston and Baton Rouge can take around 6 to 7 hours, and any lengthy delay in that can present an on-time delivery problem. Truck drivers, have a maximum limit of 11 hours of driving per day. So if there isn't availability of that truck, it can really impact upcoming production schedules for that customer. You'd start by predicting your delays up front through the predictive transit model. And at this time, it's not interfacing with an ERP system, but all it is taking in upcoming shipment data through an easy user interface like you see at the top left-hand corner here. And what it's doing is scouring all of those event data sources and outputting those into a table. That's what you see in the lower left-hand corner here, where ultimately it's going to give you an output predicted delay for that shipment and provide you all of the relevant information, such as what is your predicted rain, and it's going to give you data on that. So for this example, there is predicted heavy rain, and that is why it's being flagged. And then you'll see this repeatedly. We're going to record the blockchain, and all this is Simba's user interface. You're able to see what that transaction that was recorded on the blockchain. The risk assessment module takes all those shipments in, allows you to visualize them, allows you to input new shipments as a supply chain manager for manually identified risks, and computes the risk score based on business metrics to trigger notifications to the supply chain managers and customer service representatives. And again, you'll see us posting to the blockchain, this time using an off-chain hash. Lastly, it's going to submit an email alert to alert of a risk, and that supply chain manager will be taken to a user interface that allows you to see all of the supporting data that you need, and then be able to input any mitigation plans that were taken to be able to start generating enough data to ultimately recommend a system. And then lastly, the blockchain is actually able to let you subscribe to certain features that are stored on the blockchain, such as a customer shipment number, and you'll be able to see an email notification or text notification as a result of that. And of course, you're looking to visualize those performance metrics, so all we have is a Power BI dashboard, pretty simple to implement. Overall, we hit all of our targets for system integration and automation, but I really want to focus in on the lower right-hand corner here, which is response cycle time. Typically, at a baseline, this would take up to 2 or 5 days to go from detecting an event to responding to that with a mitigation plan. We were able to cut that down to less than 5 minutes using these automated tools, and that's a pretty significant reduction in time. So imagine the employee experience benefits there. They're able to better use their time rather than calling up people, and be able to really make a bigger impact there. Overall, how to use these project outcomes, MXD is here to try to help industry as a whole. So please follow up with me or Joel if you want to find out how to use these going forward. We recommend you start by looking at what data you currently have and assembling a diverse team. But this is a framework that can be adjusted and integrated at any kind of business processes or preferred vendor platforms, and it's modular, so you only have to implement what you want of it. And next, we're looking to really pilot this at DAO for a specific business unit, and we're of course looking for commercialization opportunities for all of these tools, including the blockchain components. But I really want to end here on some lessons learned, focusing in on the blockchain side of things. First of all, it is an enabling tool. It is not the end goal. We learned that very quickly. You don't implement blockchain for the sake of blockchain. You must define very specific business case around that, and have a reason to do it internally. There are definitely benefits to having externally facing blockchains where you're actually using that mutual trust, and this was a DAO only. It was great for transaction history, but you have to know what use case you're really targeting. You need to make sure you're proving this out with low risk incremental pilots, and I think that's what we're gonna talk a lot about today. But as you narrow this down, this new technology, We're learning it's a multiplier for trust. It doesn't replace inherent trust between multiple parties, and we saw this as a mechanism at Dow to ensure that there's really consistency and avoiding duplicative work upon multiple parties that are acting together. And overall, modular approach is key to everything. You're going to hear that a lot, but we thought that was really true to make sure that we're staying technologically current and you're able to scale with whatever solutions an eventual end user is going to want. And then lastly, we thought it was really key to have active technical support from the manufacturer in this use case, as well as the blockchain service provider and Microsoft, who is providing the cloud service. Having that really active involvement and support made this happen. So make sure when you're looking for providers that you're focused on how actively will they be involved in helping you make sure that works out. I think we'll end there with a huge thank you, and want to point out Jeremy Archbold from Dow, who is the lead and who really wished he could be here today to kind of talk about this, but we're here instead, and if you want to connect with him, please let us know.